So here we are, final topic of the lesson, breaking out of loops. So you may have a loop that has a certain number of iterations, maybe 10, and under particular conditions, you may want to skip an iteration, you may want to exit the loop early if something has been found. We're going to show a programming example of this with the prime tester program, but for now, let's just have a look at the three ways, the three statements that come under the heading of breaking out of loops. The first one, the obvious one, break. You have a for loop, a while loop, you run into a break, basically you exit the loop. It doesn't matter at what stage for I in range. I could be 1 and there could be 100 to go. You exit the loop. The continue, basically, let's say you have 10 lines of code in your loop. If you reach continue, it goes back to the top of the loop. And the pass is a little bit of an exotic one. It's essentially a placeholder. It doesn't break you out of anything, but it allows you to have like a partially complete function if statement, even partially complete loop without crashing your program. So it's a very useful placeholder and probably a lot better to do pass statements than just sort of commented out code because they're more visible. So let's have a look at each of these and how they affect an example program. So here we have a program. It's going to take a number from 1 to 10, and it's going to multiply the number by 2 and print this out. So in this case, we have a break at if number equals to 4. So this number is going to go from 1 to 10, the number in range. But look what happens. This is the output. The number is 1. Okay, 1 times 2 is 2. Number is 2. 2 times 2 is 4. Number is 3. 3 times 2 is 6. When the number is 4, we break. And so it goes to this loop completed. Then we have the continue. So we put the continue in the same place we had the break last time. And in this instance, the output is nearly complete, except when the number is equal to 4, there is nothing. Because when the number was equal to 4, instead of printing it out, it returned back to the top of the loop. And finally, we have the pass statement, which is really special, because it's as if this whole if statement wasn't here. Even though the number was once 4, the output is the same as if that pass statement wasn't there. So it's essentially, as I say, a placeholder. This allows you to write an if statement with nothing in it, except the pass, a loop with nothing in it, a function with nothing in it, essentially any type of code block. So let's have a quick practical look at how we could use break, continue, and pass statements in a program that we've already created. So in this program, we are going to experiment with the break, continue, and pass statements. So we're going to see how break can be used to dramatically improve our prime testing program from lesson 6. Then we're going to see how continue can be used to essentially ignore or sort of skip over certain inputs. And finally, how pass can be used as a placeholder. So let's start with just running this program, and let's pick a number, like 1,000,000. 1, 2, 3, 4, 5, 6. So 1,000,000, how long does that take to test if 1,000,000 is prime? That takes 0.2 seconds. I mean, I'm going to run it again. 1, 2, 3, 1, 2, 3. Yeah, about 0.2 seconds. Now, what if we just improve this program with one line of code, one little break statement right here, so that when a factor is found, any prime number with a factor other than itself and 1 is, well, any number with a factor other than itself or 1 is not a prime number. So the second that prime is declared to false, we can break, and we essentially have proven the number is not prime. So let's see if 1,000,000 takes 0.2 seconds. 1, 2, 3, 1, 2, 3. Well, it takes 7.5. It takes 7.6 millionths of a second. So this is exponent -6. So it takes 100,000 times less time, because instead of doing nearly 1,000,000 operations, this guy does one operation, and boom, we've broken out. So we can try this perhaps with like another sort of odd, non-even number, 1, 2, 3, 4, 5, 6, 7. So Let's see first of all how long that takes without the break. 1, 2, 3, 4, 5, 6, 7. That's 1.2 million. Yeah, that takes 0.26 without a break, and with a break. So from 0.26 we get to 1, 2, 3, 4, 5, 6, 7. Again, 3 times 10 to the power minus 5, so that's basically 3 over 100,000. So from 2.6 to 0.00003. As you can see, that made the algorithm dramatically better. So let's now look at the continue state. What can we do? I don't know, like prime numbers may not be the best example, but quite often you may want to make an exception for something. So let's, for the sake of argument, say we want 8 to be prime. So instead of just doing a statement where we set 8 to prime, we can essentially ignore these operations for 8. So something like if num double equals to 8, we can continue. So that would essentially skip everything below here, as long as num is 8. So we're going to test 8, which has got a whole bunch of factors, and it's going to come out as a prime number. We can ignore divisibility by perhaps some other number, like let's say you're going to ignore factors of 5. So most numbers are going to be correct. So like if you say, 5 is going to be a prime number, but 25, which has only got one factor, which is 5, is going to get this operation skipped. So 25 is going to come out as prime. So these are some examples of how you can use continue. And finally, let's have a look at how we could use pass. Let's say that you want to do a custom comment that you're not quite sure what the comment is going to be. So, like, a lot of nerds love jokes about the number of 42 being the meaning of the universe. So we can actually say something like this. If num double equals to 42, and let's say we don't know what to write, what comment. We can just say, here, write a joke about the meaning of the universe. And we're not quite sure what to write there, but we're sure that we want to write some comment. Well, we're going to get an expected indented block indentation error. However, if you just use a pass, above or below a comment, doesn't really matter, this is going to work just fine. See? 55 is not a prime number. So that's an example of the usage of pass as well. All right, I think that's a wrap.